Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on tNavigator, and we will again use the sample case from tNavigator. And today's topic, we will talk about using arithmetic to find or to make filters for connection. What did I mean by that? You will understand soon. All right, so yeah, just a background. Usually, when we handle a model, particularly a big model, sometimes we want to focus on the connection. Connection in this case is the connection between the well bore, and the grid. Okay, I want to know where the connections are. And sometimes, especially if the model is too big, it's a little bit uncomfortable and it takes time to find the connection. Okay, so let me just demonstrate it to you. So this is our model. We are currently looking at pressure map in 2D, and this is the porosity, permeability. It's okay, it's a simple case. Okay, nothing actually very special. And if you want to know the master data, it's like this. Okay, we have run spec, the title. Yeah, we use defines here, but that's not our main subject today. And start, metric, univout, oil, water, gas, and this gas for reservoir below the bubble point pressure. Implicit, the dimension, rec dims, step dims, nothing very special. And this is multiply, but it is not involved in the coding. And copy, we use permeability X to be exactly the same as the permeability in Y direction. And props, stones, this is our PVT data. This is our relative permeability data. And this is for the region. And we define some zones. Okay, but again, the main point today, we will learn how to find the connection. Okay, so let's go to the 3D, and I'm going to move across the time slider. Okay, first I want to show you how to find the connection manually. So manually it's like this. It takes time. So you just zoom in like this, and then you touch this one and you check the location of the cell. So it's located at, in X, it's 11th layer, and in Y, it's in at 9th layer, and the first layer. So that's the location, the position of this grid, this cell. And we can go here, 3D slicing, and first we can untick everything here, uncheck all, uncheck all, okay. And the location is at 11, so I will check this one, and at 9 for the Y or J direction. And let's say I want to maintain all the Z or K layers. And currently here we are looking at the union fission, but let's say I want to change it to intersection and click on OK. So I will maintain only this one. Okay. And you can go again to the this one. You can you can check everything and you will have that one. So it's like cross section. Or you can also deselect everything, and you will, yeah, the grid will be hidden, and you can check everything here and just tick 1, 7. or 5 or like this. Okay, something like this. And you can check everything, but deselect all K layers, and you want to see this one, the top one, and you want to check also the bottom. It's like this. Okay, and something like this. Okay, that's the manual approach. But even in that case, let's say if we check everything, okay, and then just maintain 11, 9. Even in this case, I cannot really focus on the connection. Yeah. Please notice that not all the cells here are connected to the wellbore. Okay. And I cannot see the connection. I need to go here, graphs, and go to wells, and which well it is? Well 8, and go to well 8 here, and you can move this time slider, or maybe you need to run. And yeah, later you will find this connection. Okay, let's say just run. Yeah, here. This circle, means the connection. The wellbore, this cell is connected to the wellbore. Okay, so that's the symbol of connection. Okay, but still, I want to know which cells are actually connected to the wellbore, or each wellbore, each connection at each wellbore are connected to which cells. Okay, so that's the game plan there. And let's go back to here, go to union, or maybe intersection, and select everything and go back to union. Okay, so this is our model. And to find the connection between the cell and the wellbore, okay, we can go here. Yeah, after running, we go to user cut. Okay, and you check here, we have arithmetic command line, and we will play with arithmetic now. Okay, so in arithmetic command line, you can type in this WMC, and then open parenthesis, and then just type in this one. Okay, and then comma 1, and then apply to cut, and then just tick this one. So what do I mean by this? So by using this arithmetic command line, I can very quickly identify which cells are connected to my wellbore. Okay, I don't actually understand what these letters mean, but maybe W stands for well, M, I'm not so sure, but M I think is the mask, and C is connection. Okay, and yeah, this is the detail. This symbol, this star, corresponds to a mask used to select wells. Okay, and 1 here is condition for a well, for the well, for all wells. So by using this, I can quickly identify which cells are connected to my wellbore. So you can just use this code or script, and you will find the connections in your all wells. Okay, so if we zoom in, you see, and we can also take grid lines. Okay, so this is the cells, and this sort of ball shape is actually the connection. Okay, I can untick show grid, and you can see something like this. If there is no connection, then it will be like this. It's just bolt, empty. Okay. But if you find something like this ball, like this shape, it means connection between the wellbore and the cells. Okay. And by using this command line, we can quickly identify all wells. Okay. So again, W well M may be mask. Okay. As in masker. All right. And then C is connection. And to this corresponds to mask used to select the wells. Okay, so using this, we want to say to tNavigator, I want to find wells. All right, and one here means this is the condition for the well. Okay, this is the condition for a well. Let's check what if I use 2. Okay, and what if I use 3? What if I use 0? All right, you see? But if I use 1, yeah. And what if I use 100? So 1 doesn't really contain a big meaning. So it's a condition for the well, and it is applicable for all wells. Okay, so I will use 1. Okay. Okay, so again, by using this, only the blocks which include connections are visualized. Okay, the blocks or the cells which include connection to the wellbore will be visualized using this command line. Okay, yeah. If you're currently handling a simulation, you will very soon understand and you know understand the meaning of this, the importance of this, the usefulness of this. Okay, especially if you are handling a big model. And then let's say I want to select producers. Okay, so here we are locating both producers as well as injector. Now I want to find only producers. Okay, so again, by using 1, I mean all well. Okay, producer or injector, gas injector, water injector, you name it. But if I only want to know the producers in this code, I can use ORAD. So it means oil rate, ORAD. And to be a producer, let's say ORAD greater than 0. Okay, and click on apply. You see the connection will be lost, or the cells will be hidden for the injector because it's not producer. Okay, the ORAD in this well is 0. Okay, never mind greater than 0. It's negative because it's injector, right? So again, WMC and star, okay, and ORAD greater than 0. Let's say if we want to use greater than 100, okay, so we put even more specification. I want to find connections which give me more than 100. So you can do that, okay? But if you just want to know the producer, then of course, 0 is this 0 is sufficient, okay? So again, by using this command, only blocks with producers or only blocks, only cells with producer connections are visualized. Okay, it's very easy, but very useful. And let's say I want to select blocks or cells with producer connections, but with high oil saturation. So I will put even more focused comment. And I will add N here, and the comment will be as oil. This is for oil saturation, let's say greater than 0.5. So if I use N, it means that only cells which meet both requirements will be visualized. Okay, first I want to, the first requirement is that it needs to be a producer, and the second requirement, it needs to have, saturation of oil greater than 0.5. And let's say if you click on apply, okay, you will find the cells that I think the most important cells in this case, because the cells have, saturation of oil greater than 0.5.